In this video, I will be doing a review for Chapter 11, specifically 11.4 to 11.7, which is all about series and sequences, arithmetic, and geometric, finite, and infinite. Alright, and this content can be found starting on page 608 of your textbook. So, one of the big ideas that I need to be able to understand and conquer is if I give you a rule for a sequence, you should be able to find any desired term. So that means if I give you something that looks like a sub n equals whatever, you should be able to, if I ask for the first three terms, you should be able to give me the first three terms. And you do that by plugging in, well, 1. If I plug in 1, that gives me my first term. If I plug in 2, that gives me my second term. If I plug in 3, that gives me my third term. And if I ask for the 10th term, what are you going to plug in? 10. Alright, and then you actually do the algebra, and you get 1 minus 3 here, 1 minus 3, which is negative 2. So your first term is a sub 1 equals negative 2. A sub 1 equals negative 2. That's what I would want to see. Here you would get 4 minus 3, which is 1. So a sub 2, your second term, is 1. A sub 3, you get 9 minus 3, which is 6. So a sub 3 equals 6. And your 10th term, for example, is going to be 100 minus 3, which is 97. So a sub 10 equals 97. If I ask for the first three terms, I think it would be alright for you to go ahead and list them as negative 2, 1, and 6, because this is a sequence. Alright, so you can list them like so, or like this over here, or if I ask for the 10th term, you can give me a sub 10 equals the value that it comes out to. Another thing that you need to be able to do is graph, and I do have another video that actually goes over specifically graphing. So whether I give you the actual terms of the sequences here, and you have to remember that you can put it into a t-chart as my first term is 2, my second term is 4, my third term is 6, my fourth term is 8, and my fifth term is 10. Or I give you the rule and you actually have to plug in the numbers and give me this t-chart and give me those points. Either way, you're going to get x values, you have input values, and you have output values that give me points. Always and forever, your domain for sequences and series, your domain starts at 1 and goes up integer by integer, 2, 3, 4, ... Right, keeps going. So if I were to graph this, 1, 2, and my y's over here, they go up by 2's, and my x's go by 1's. So this is 2, 4, 3, 6, 4, 8, 5, 10, I believe. Alright, so this would be an example of an arithmetic sequence, as it is the graph of a line, and it goes up by 2. We're adding 2 every single time. Our common difference is a positive 2. Something else I need to be able to do is find the sum of a series. So we were given in the book, you guys do not have to remember this specifically, we were given a couple of formulas for arithmetic and for geometric sequences and series, which are for arithmetic n a1 plus a sub n divided by 2, and this is a sub 1 minus r sub n over, or sorry, r to the nth power, or 1 minus r. I should be able to find the sum of these. What these really tell you is, alright, if this is for arithmetic and this is for geometric, if I have a list of numbers, if I'm given the sequence, all I'm really doing is adding how many ever terms it tells me. So if it asks for S sub 4, that means you are adding the first 4 terms of the sequence. So that is what this example is telling me. I want S sub 4. So S sub 4 here, I need the first 4 terms of the sequence. And I could use this formula, as that one is arithmetic. However, I could also put in the legwork and actually find the first 4 terms. So if I plug in 1, I should get 2. If I plug in 2, I get 4. If I plug in 3, I get 6. If I plug in 4, I get 8. Those are my first 4 terms. So what I do is I add them. 2 plus 4 plus 6 plus 8. And that should give me 20. So S sub 4 equals 20. That means I'm adding my first 4 terms. So if I ask for the sum, you should be able to work out an example like the first one up above, and as well as an example like this, where you find how many ever terms they're asking. I'm not necessarily going to require you guys to be using these formulas, as we did not cover those in depth. Another big idea is determining what kind of sequence you have. So, is it arithmetic, is it geometric, or is it none of the above? So you are trying to determine whether you have a common difference or a common ratio. Are you adding and subtracting, or are you multiplying and dividing, or none? There's no consistency. So here, I am subtracting 7. I'm subtracting 7. I am subtracting 7 for every single one of these. That means it is arithmetic, and my common difference here is minus 7, negative 7. Here, I'm adding 2, but there I'm not. I'm adding 4. However, so that makes it's not arithmetic. Since I add 2 and then I'm adding 4, that's inconsistent. So let's see if it fits geometric. I multiply by 2, multiply by 2, multiply by 2, multiply by 2. That actually does work out, so it is geometric. And my common ratio is positive 2. Alright, you need to keep in mind if it looks like 32, 16, 8, you are dividing by 2, which makes your common ratio 1/2. Make sure that 2 is down there in the denominator. That means you're dividing by 2. And here, let's go ahead and see, I add 2, and then I add 4, and then I add 8. Alright, so am I multiplying by anything here? That was inconsistent, so it's not arithmetic. Is it geometric? So what do I multiply 1 by to get 3? Multiply by 3. What do I multiply 3 by in order to get 7? That would be 2 1/3. Multiply by 2 1/3. That doesn't quite work out. So this is not geometric either. So that means this is none. It's neither one of those. Another big idea is to find your rules, so finding an a sub n. For arithmetic, our a sub n, I gave you a different formula than they gave you in the book. However, it will work out the same exact way. dn plus b. And for geometric, I do use the formula that's in the book, a sub 1 times r to the n minus first power. So the big idea here is plugging in the information that you are given in order to find a missing piece so that you can get your rule. Alright, so here I'm given my common difference. So I'm given my d, so a sub n equals 5n plus b, and I also have an input and I have an output. So my output is 33, that replaces my a sub n, and in order to get 33, I inputted 5. So this way I can solve for b. So here I would get 25. So that means I would subtract 25 by both sides, and I would get b equals 8. So my a sub n equals 5n plus 8. And that would be my final answer for that. Here I actually need to, in my second example for arithmetic, I need to find my d first. So what did I add by? I added 6 every single time. I added 6, so d equals 6. And let's go ahead and use my second term, why not? So my input should be 2. So 6 times 2 plus b, and my output here is 2. So this is my first term, my second term, input, output, and I get 2 equals 12 plus b, so b equals negative 10. So my a sub n, I need to keep my d there, 6n minus 10. Alright, and that's for arithmetic, so it should come out to something that looks like y equals mx plus b, or a line where I have a slope and a y-intercept sort of piece. For geometric, I may be explicitly given a sub 1 and r, or I may have to find them just like I found b. So here, a sub n equals 1, r is 3, and n minus 1. I actually don't need to find anything here. Since this means I'm just multiplying by 1, I don't even need to write it. So a sub n equals 3 to the n minus first power. In my bottom example for geometric, I actually do need to find it. So the only thing I don't have here is a sub 1, so I'm going to plug in everything else. My output is 24, and I need to find a sub 1. My r is 2, and my input, in order to get out 24, was 3 minus 1. Alright, so 3 replaces your n. So that means I get a sub 1, 2, 3 minus 1 is 2, so that's 4. So 24 equals 4 times a sub 1. So a sub 1 equals, if I divide each side by 4, 6. So then I can now write my rule as I have my a sub 1 and my common ratio, 6 times 2 to the n minus first power. And right there is your rule. And last but not least, you also need to be able to find the sum of an infinite geometric series if it exists. So the formula for that was the sum is a sub 1 over 1 minus r. And you need to pay attention to whether that absolute value is less than 1, because that will work. Or if the absolute value is greater than or equal to 1, there will be no sum. So one example is a sub 1 equals 5 and r equals 1/2. Alright, well, r equals 1/2, that falls into this category, so I can go ahead and find my sum by plugging in a sub 1 and r. Alright, so that would be 5 divided by 1/2, which is 5 times 2 over 1, or 10. And another example would be a sub 1 equals 1 and r equals 5/2. Here, the absolute value of 5/2, or 2.5, is greater than 1, so that means there would be no sum. And really the big idea of this is if you graph these two different examples, this graph would keep on going up and up and up and up and up as you add each term. It's going to approach infinity. So there's no definite sum here. Whereas this graph would approach what is called an asymptote. So it would approach here, this value would be 10. So as you add terms together, it's going to keep getting closer and closer to 10. So in order to actually see that, let's go ahead and find, well, our first term here is 5. if I find my second term, so I can plug it, I can find my a sub n. This is just overkill here, I don't need to do this. A sub 1, r is 1/2 to the n minus first power. So I'm going to take a second and get rid of some of the work on the page so that you can see what I'm doing. Alright, so this is a geometric sequence. So I can have my input and get out an output. So I could be able to graph those points of the sequence, or I could graph the series, which means I am adding one term and then two terms together and then three terms together and then four terms and so on. So if I plug in 1 here, I get 5 times 1/2, 1 minus 1, which is 0. So anything to the 0th power is 1. So this outputs 5. If I were to plug in 2, that is 1/2, 2 minus 1. The 2 minus 1 is 1, so it's 1/2 to the first power, which is just 1/2. So 5 times 1/2. And I know since my ratio, instead of inputting it every single time, I'm multiplying by 1/2. That's 5/4, and then 5/8, and then 5/16. So that means for my series on the right side over here, my first term I have 5, but then I add 5 plus 5/2, and then 5 plus 5/2 plus 5/4, and you would see that these values, these output values for your series, that means you're adding one more term each time, they're going to get closer and closer to adding to 10, but they never quite get there. So the difference between graphing a sequence and a series is sequence, you strictly have an input and an output with your n and your a sub n, versus here you actually have to add outputs together to find your s sub n. Alright, I will see you guys tomorrow. Good luck studying.